Welcome to Part 2 of the Integrity Testing video series. In Part 1, we looked at what is happening in the pores of the membrane during the test. In this video, we'll look at how the test is applied to process scale filters and demonstrate best practice operations. Let's begin by looking at the key components of the system. It is important to be able to control the wetting flow rate using valves and to be able to monitor the flow with gauges or a flow meter. Ideally, we have gauges immediately upstream and downstream of the filter in order to get a clear assessment of the differential pressure. It is important there are no leaks in the system. Assured gaskets are in good condition, that clamps are snug, and vent valves are in good working order. When using automatic testers that determine flow based on upstream pressure changes, it is critical for the filter system to be in a stable temperature environment. Even small changes in temperature can create inaccurate results. Ideally, we want to place the filter to avoid heat or air conditioner flow, or proximity to heat sources such as autoclaves or steam pipes. If the filter is steamed or autoclaved, allow the system to fully cool before testing. Cooling can be accelerated by air or water flow. System temperature equilibration is more of a concern with stainless steel filter housings than with plastic capsules. For accurate results, it is important the membrane be completely wet. Membrane wetting is often thought to be a challenge, but it doesn't need to be. To assure robust wetting, there are two operational details. With the outlet closed and the high point vent open, slowly fill the housing. There is no specific guidance for the time to fill the housing, but 30 seconds to a minute is a reasonable target. You want to avoid blasting the filter with water, that is, filling the housing in a second or two. This can result in air trapped within the membrane structure, a condition known as airlock. Trapped air can impact both diffusion or bubble point results, and trapped air can be very difficult to remove. Often the only remedy for airlock is to completely dry the filter and start over. When the housing is full, close the vent valve. With the outlet closed, the pressure in the housing will increase to whatever pressure is available at the inlet. Generally, we target 40 psi, but whatever pressure is available will suffice. Let the system stand at this pressure for 1 minute. After 1 minute, open the outlet valve and adjust the flow to the recommended minimum of 1 liter per minute per 0.1 square meters of filter area. A flow meter is a good way to monitor the flow. If a flow meter is not available, monitor the differential pressure. For the typical 0.22 micron rated Durapore device, the differential pressure at 1 liter per minute per 0.1 square meters of filter area will be about 2 to 3 psid, or about 300 millibar. Maintain the flow rate for 5 minutes. When using an automated test instrument, attach the instrument connection to the highest point upstream. Assure vent valves are closed tightly. Assure the outlet is open to atmosphere. And start the test. Test progress can be monitored during the test. All integrity test instruments typically display some combination of system pressure, pressure decay, or gas flow rate during the test. By monitoring the pressure or flow trends, you can check for problems. When the test is complete, you will want to evaluate the results to assure the test was performed correctly. If the test failed, reviewing the printout can also provide important clues as to the possible root causes. Here is an example of a printout where there was a false failure due to temperature decrease. You can see the gas flow trend is not steady. If you see this result, look for and eliminate a source of temperature change before running a retest. Here is an example of a false failure due to an upstream leak. The gas flow trend is steady, but it's marginally higher than what is expected for an integral filter. These and many other test result examples, along with lecture and labs, are used in our 2-day training course, Operator Certification for Automatic Filter Integrity Testing. The course objectives are to teach the test principles, proper execution, and results assessment skills that will assure accuracy and efficiency. Reliable integrity testing does not need to be challenging. With an understanding of the filter's gas flow behavior during the test and adhering to basic principles, we can greatly eliminate false or confusing results and assure our goal of first time, every time success.